Okay, so today we will continue with the cluster Hadoop sub-projects. So cloud sub-projects. We have seen so far Hadoop and MapReduce, and we have seen the HDFS, the distributed file system for Hadoop. And so now we will go into some sub-projects of Hadoop. We will look at 4 sub-projects today. The first one is Pig, which is a high-level language for data analysis. So we will look at that separate programming language that helps us with more complex analysis, so writing less code to achieve the same results as we would do with MapReduce. Then we will look at another tool called Hive. This tool allows us to import structured data onto the Hadoop distributed file system and be able to issue queries in the form of SQL language. So we have this Hive QL language, query language, that we can run these queries against a store of data. And the other thing we would look at is HBase, which is another form of storing data, relational data, but instead of doing it the same way as the relational databases that work on rows, this stores the data by columns. And we will look at another tool called Storm, which is for streaming data and real-time data computation, so with high fault tolerance. Because most of these tools that we have seen are batch for batch processing, but sometimes we have real-time and streaming data, so none of these provide the analysis for this type of data. So we will look at the Apache Storm. A Zookeeper is another tool, sub-project that runs on Hadoop that is not a tool in itself like the other ones we're talking about, but it's more like a platform that allows high reliability and for distributed applications. So we will start with the first tool called Pig. As we mentioned, the Pig is a high-level language. High-level language for data analysis. It started at Yahoo Research. So Yahoo invented this high-level query, high-level language, and now more than 30% of the Yahoo jobs run on these. So it works. It expresses sequences of MapReduce jobs, so it will run MapReduce jobs, but it's a high-level language that allows us to, in much more short pieces of code, accomplish what we're trying to do. It uses nested bags of items, and then it provides some relational operators like join and group by. It's easy to plug in Java functions into this language. So this is a scalable language because it's due to its simpler design. There are no transactions. All the operations that it does can run in parallel, so parallelizable. And it has a procedural control in a sort of a pipeline, a processing pipe. So we do need this high-level language semantics are hidden. It's flexible and it's scalable, and it's also cheap. So we mentioned that it provides this group by and join operator. So if we have a user data in a file, let's say it's the file is about users using websites. So what kind of websites do they go to? And we want to find the top 5 most visited pages by users that are of particular age, in this case 18 to 25 years old. So how are we going to do this? We need to load the user's data and then do some filtering by age. So how we would filter by age? We can join on name, we can group on URL, count clicks, or try to order them by the clicks that they took, and then find the topmost. So if we are to do this in MapReduce, this is the amount of code that we have to write. But with this Pig language, Pig Latin, because it's a high-level language and it has these general data flow operators that we mentioned, then the code will be much shorter. So this is the code that if we write this in Pig to accomplish the same results. So it's a high-level general data flow language. So it operates directly over the files. So over here, load users. So it operates directly over the file. And over here, load pages. So what you will notice here, the user and URL, these schemas are optional and they can be assigned dynamically. The red color, so this is the input files and the output files in the blue. And the red color you have the Pig operators, so as load, and store. This is for working on the files, and then operations on the data, join, group. There could be some loops implemented, such as for loops, and then do some counting. But the red ones are the operations that the Pig language provides. So a step-by-step process for creating a program in Pig is much cleaner and simpler compared to the MapReduce. It's easier to keep track of what the variables are and where we are in the process of analyzing the data. We can have interleaved clauses of SQL. And so if that's the case, it's hard to tell sequentially what's happening. But with this Pig language, the data nesting and the temporary tables are abstracted away from the programmer. And so Pig has fewer primitives than SQL does, but it's more powerful. So user-defined function can be used on every construct. So, for example, filter and for each. So these will be some user-defined functions in here. So it makes the translation much easier. It does create MapReduce jobs, so this is what it's going to do. That's going to be load the users and load the pages, filter by age. So this is going to be the first job, the red one. Then the green one will be job number 2. So group on URL and count clicks. So over here, sorted and top 5, those functions will go into a separate job. And then job 3, order by clicks and take the top 5. So these could be, there are, like we said before, there could be more than one mappers doing the same functions, but it does run on top of MapReduce, so it does issue batch jobs for it.